Hello everyone, welcome to this lecture video. In the operating system, we are in the unit 2. We are in the lecture series. We are having discussing about the deadlock and introduction about deadlock, how the deadlock avoidance happened in the previous video. In this lecture video, we are going to discuss about the safe and unsafe deadlock and how the deadlock can be avoided. So in this picture, we can able to see the safe state is the without deadlock we call it safe, and with deadlock we have it will be the process will be in the unsafe. So avoidance of this can be the different kinds of algorithm used. So avoidance algorithm can be single instance of resource type, use of resource allocation graph, multiple instance of resource type, use of the Banker's algorithm. So in the resource allocation graph we can have the climb edge, and also P indicates R, indicate the process may be request resource and represent dash line. So climb edge converts the request edge when a process requests a resource. So request edge converted to assigned edge when the resource allocated to the process. So here the resource must be climbed a prior in the system. So resource allocation graph will be a process one will be a allocated resource 1 will be allocated to the process 1, and process 1 will be allocated to the resource 2. In the resource we have process. In the picture we can able to see resource allocation graph. Process P2 will be allocated to the resource 1 and P2 will be allocated to the resource 2. So resource allocation graph. In the unsafe we can have the we can have the things we are using here. So unsafe resource allocation graph, we have suppose the process P1 request RJ, the resource can be granted only if the converting the request edge to assigned edge. So does not request results in the formation of cycle in the resource allocation graph. So we are familiar with the algorithm. Most popular algorithm used in the deadlock avoidance is the Banker's algorithm. The multiple instance, each process must have prior climb maximum uses. When a process requests a resource, it may have to wait. When a process gets all its resources, it must return them into a finite amount of time. So we can have Banker's algorithm. So in the data structures for Banker's algorithm, we can have the available, max, and also in the Banker's, I'll continue to do that. The data structures for Banker's algorithm, we can have the available, max, and allocation and needed. This n, let's n equal to number of process, total number of processes in the n, and m equal to number of resource types. So safety algorithm, we can have the let works and finish be vectors, length and m respectively. Here work equal to available, finish have the things we are having. Find a such both that finish equal to false and need less than equal to. Here the some safety algorithm we are using here. So resource request algorithm for process, resource equal to request vector for process P1, and P1 wants the request go to the, otherwise the rise error condition, and request I will go to the things. So available equal to available minus request, and our allocation equal to allocation plus request. So if saved, the resources are allocated to the PA. If unsaved, the PA must wait and the old resource allocated state is restored. So here the examples of Banker's algorithm we can able to see here. So 5 process through P, so snapshot at time, allocation max available. So in this case we can have the examples of Banker's algorithm. So P process P0, P0, P1, P2, P3, and etc. P4. So here ABC are having the things we can have 0 1 0 2 0 0 3 0 2 2 1 1 0 0 2. So maximum available of ABC 322 902 222 and 4333. So we can having the 5 process through P1. So A of 10 instances, B of 5 instances, and C of 7 instances. So snapshot at a time will have these kinds of things. So we can have the maximum allocation. So ABC will be the 743, 122, 600, or 011 and 4311. System is unsafe if the state the sequence of satisfy the safety criteria. So P1 have request deadlock detection can be allowed system to enter deadlock state. So detection algorithm, recovery scheme, and other things. So periodically single instance of each resource type, we can have the resource allocation graph and weight graph we are having. So resource allocation graph having the R1, R3, R4 and R2, R5. So P1 process will have the resource allocation graph, corresponding weight for the graph. P1, P2, P3, P4 and P5 will be resource allocated for the corresponding graph. So in this resource allocation graph and weight for the graph will having the different kinds of process. So will be available in the resource allocation graph and corresponding weight for the graph. So several instances of resource type will be available and allocation and request. So vector of length will be indicates the number of available resource type. So allocation NMTM matrix defines the number of each resources, each type currently allocated to the each process. So these kind of things we can have the several instances. So detect algorithm and other process. So we can see the how the recovery from deadlock can be process determination while involved. So thanks for watching this video. I hope you all understand what is deadlock and deadlock avoidance and how the bankers algorithm used in the familiar algorithm can be predicted for the deadlock avoidance in the operating system. Thank you for watching. Thanks.